Okay, so analytic trig. Some background stuff that we talked about yesterday, we'll expand a little bit farther. Let's say you had this. Do you remember that this is both of these are perfect squares, and therefore they both have square roots, and therefore you could rewrite it like this: sine, and not sine squared, but sine and sine, plus and minus 4 and 4. Does that ring a bell?
Yeah.
Okay, so why do we need that? Because then later on, you'll learn, like, for instance, you can replace this with something else and do a substitution. I'll do one that's like that. Do you remember this one? Sine squared plus cosine squared equals 1. If you don't have that memorized, memorize it. That one you have to just know. It comes from the triangle. And the triangle that we had looked like this. I'll zip to that quick. Right there. And this was cosine. Not squared, sorry. And this was sine. And this was 1. Do you remember that? And this is this squared plus this squared has to equal this squared. That's where that comes from. All right, so back to, if we start with this formula right here, that's something you just have to memorize. And then it'll tell you a whole bunch of other functions after you've got this one down. All right, I'd like you to, if you haven't already, copy that down, please. And then I'd like you to take and divide it all by cosine in your head and write what you get then. Now, maybe that's too much to do for some of you in your head. So maybe you should do it on paper. Divide by cosine. Divide by cosine. I hope you recognize that one at least. Cosine divided by cosine? Come on. Yeah. Okay. Oops. There would be a theta there. Okay. So now if I've done that, I should have a new one. I'll write it in blue. Sine over cosine is tangent. Plus 1 equals 1 over cosine. What's 1 over cosine? Secant. See how that's a new one? That's a lot like the red one. Oh, what just happened there? It's annoying. Okay, there. That one and that one are two big ones. And now go back to the original one, and instead of dividing it by cosine, divide it by sine. All right. Oh, I should have said theta. I'm sorry. Some of my problems have x, some of them have theta. I know. Stop, please. Thank you. All right. So go back to the original one. Now divide everything by sine. Now, I saw somebody saying in the back row, that's the only one I know. That's okay. That's okay. Because you can get all the other ones from it. So now I know this one. And what's the one I just asked you to do, where you divide everything by sine? What's sine divided by sine? 1 plus, what's cosine divided by sine? Cotangent is equal to 1 over sine, which is cosecant. So there's my third one. These are all what are called Pythagorean. And you're looking for these. Anytime the problem has a plus 1 in it, it's probably going to be one of these. Like, let's say that was in my problem. Tangent squared plus 1. You can replace that whole thing I circled in red with secant, if you know these facts. So there's one that you get from here. You got to know one, and it can grow the rest of them from it. It's sort of like the arc. There was a movie that had the idea of an ark where if the whole earth got destroyed, they were going to save a whole bunch of like little seeds and stuff from all these plants that they wanted to be able to keep around to start over again. So like if the whole earth got wiped out with like a nuclear disaster and the people were able to survive, they have this vault in like Sweden where they have like some of everything so that we could somehow try to bring back the earth as we know it. It's kind of a cool idea. Anyway, if you just had this one little seed right here, You can grow these from it. Along the same lines, we can do something else for the other kinds that you have to know. And I'll show you those in a minute. Question? Yep. Yes. Yes, it does. If you start with things that are squared, you got to keep going with things that are squared. Yes. All right, that came from, where did the question is about where did tangent become sine over cosine? That's from this one. Would you agree that tangent is the opposite over the what? TOA. Adjacent. That's why it's sine over cosine. Get that? All right. Now back to where we were here. Under background stuff, if you ever saw this, 1 squared minus sine to the 4th of theta, you should be able to factor it. Well, you take the square roots, right? What's the square root of 1 squared? 1 and 1. What's the square root of sine to the 4th? Sine squared and sine squared. And then a plus 1 and a minus. Or one of them is plus and one of them is minus. Did either of those look like something that you wrote on your paper a second ago? Which one? The plus or the minus? Okay, so you had sine squared theta plus cosine squared theta equals 1. And if you wanted to get the cosine solved all alone, we could subtract sine from both sides. Side is a goofy yes. Why would you? Because you want to get cosine squared is equal to 1 minus sine squared. And you see that is right there. So I could replace this right here with what? Cosine. See? Right there. So now I can replace that with a cosine. That's what this is all about, is trying to simplify things down farther and farther and farther and farther. All right? Okay. Moving on, other background stuff. Common denominators. You need to be able to make common denominators. We talked about this yesterday, so for just 2 seconds here, tell me, what would be a good common denominator for these? B times x plus 1, yes, which would be bx plus b. All right, so we'd have to multiply this one by x plus 1 and x plus 1, this one by b, and then I could add the tops and leave the bottom the same. Notice if I add 5/7 plus 1/7, I don't get 6/14, I get 6/7. The denominator stays the same, see? It stays the same. So this denominator stays the same. And so the denominator would be b times x plus 1. And the top of it would be 2x plus 1 plus b. All right. To be able to handle the trig stuff today, you have to be able to make a common denominator. All right. Here's another one with a common denominator we did yesterday. Quick reminder. Remember how we multiply by x on the top and the bottom of this one? Why can I do that? How can I multiply by x over x? Because it's multiplied by 1. All right, so then all of a sudden the bottom of this thing would become 2x minus 1 over x. And on the top I have 2 minus x. Then it's a fraction and a fraction. So you could change this to a multiply by its reciprocal. So put x over 2x minus 1. And now it's a multiply problem. And there's a 1 on the bottom over here. All right, anyway, I'm just trying to remind you how you can do fractions in fractions, because it might come in handy later. This is quadratics. It's something squared, something not squared, a constant, and it equals 0. That's a hint that you're trying to do a quadratic. All right, in this kind of a problem, I would recommend that you replace it with just an x, and you'd write this. X squared plus 2x plus 1 equals 0. See what I just did there? I replaced the sign with just an x. Now I could solve it, and let's say I come down to an answer of x and plus 1 and plus 1, so x equals negative 1. Now I got to sub it back in there. I was cheating by replacing sine x with an x. Now I got to go back and put a sine x here. And I have to finish the problem and say sine of what angle. I need to find an angle. So I'd use inverse trig, and I'd end up figuring out that the answer is a degree. Okay, moving on. This one, we talked about these. It's called the Pythagoreans. This is the first kernel, the seed that you can use to build all the other ones. All right? From this, if you see cosine squared theta, you should be able to just right away say, oh, I can replace cosine squared with what? 1 minus sine squared. Okay? Got to be able to solve that in your head and say, well, if I want cosine alone, I take away sine squared on both sides. And cosine is 1 minus sine squared. All right, moving on. The other kinds, you need to know the reciprocals, like the ones that are evil twins of each other. So sine goes with 1 over what? And every one of them has one of those. Would you please just refresh your memory by making all of these? And it's not cosine, it's 1 over cosecant. Make the list of all 6. Rapido, por favor. These reciprocals come up a lot. They really do. And they're some of the easiest ones. When you can sub in a reciprocal, it makes things cancel. So these are really handy to know. So sine, cosine, tangent. And that doesn't really matter the order after this, but I'm going to do cosecant next. And then I'm going to do secant. And the last things I'm going to do is cotangent. Okay, cosine is 1 over, which one goes with cosine? Secant. Theta, sorry. I should just use one letter the whole time. Tangent goes with 1 over cotangent. But, this is important, tangent could also be something else. Yes. So if you ever saw sine over cosine, you should put tangent. Unless it'd be better to put 1 over cotangent, because they're the same thing. All 3 of these are the exact same. So they're all interchangeable. Whenever you need a different form, just pull out the one and put in the other. Okay, next one, cosecant. Cosecant's 1 over sine. Secant, 1 over cosine. And the last one is cotangent. 1 over tangent, or cosine over sine. Very good. All right, so there's reciprocal ones. See how many things you know? And you sometimes you say, I don't know any of these. I bet you knew all of those. So that means there's like 12 things that you could substitute for each other. All right. Yes? Oh, the opposite ones are coming up here. They're coming real soon. The quotient ones are just the one like sine over cosine or cosine over sine. Just to keep it straight, this one's the one to remember. That's tangent. And then you can remember that the other one is cotangent. You flip it. Okay? So tangent has sine on top. All right. The Pythagorean ones, that's the kind we keep coming back to. They're really important. Anytime you see something squared, it's probably one of these you're going to end up getting. There's one problem in your book that has this, or one problem in your worksheet that has that, in the thing I circled in blue. And you can replace all of that stuff with what? 1. So you can just put a 1 there. It'll be really a freeing experience. You can get rid of all this complicated stuff in the problem, replace it with a 1. All right. Next thing, cofunctions. If I have a little triangle and this one's 50 and this one's 40, sine of 50 could be replaced with cosine of 40. Here it is a little more complicated. Sine of theta could be replaced with cosine, but not of theta. 90 minus theta, except we wouldn't say 90. Pi over 2 minus theta. So here's the harder one. It's the same exact thing when you see this, like tangent of pi over 2 minus theta can be replaced with cotangent. Now, don't mess this up. Of what? Theta. I mean, look at this one. See? It's a simple theta. Goes with pi minus, or pi over 2 minus theta. So if you're coming across a problem and it's got that in it, you can just replace it with that. It's a lot simpler. And then if you want to replace the cotangent with 1 over tangent, that's fine too, because they're reciprocals. All right. Odd even identities. Here's another kind, the one you were talking about with the negatives in them. All right. So let's say I had sine of theta equals sine of theta. Can't argue with that. Please write all three. Cosine, theta, cosine, theta, tangent, theta, tangent, theta. And the point of these is when you make something negative, will that change the answer or not? And in 2 of the cases, it will. In 1 case, it won't. Which 2 are the same as each other? Sine and tangent. And if you make their angle negative, does it affect the answer or not? Yes, it does. On cosine, if you make its angle negative, does not affect the answer. I have an example of that right here. This is a positive 30 degrees. This is a negative 30 degrees. Do you see that the answer for both of them, cosine is the x part, the answer for both of them is positive root 3 over 2? See how it doesn't matter if it's 30 or negative 30, the answer's still positive? All right, so cosine is special that way. All right, so you're going through a problem and you come across this. Cosine of negative 30 degrees. What can you replace that with? Don't change it to a different thing. Cosine of 30. Now, could we, now that it's positive, can we take cosine of 30 and replace it with something? That could be sine of what? 60. See how this turns into this, which turns into this? They're all equal. So you have to be able to see whenever there's a negative like that, we must be talking about these guys, the odd even ones. By the way, these are the odd ones. Sine and tangent are odd ones. And it's kind of like counterintuitive to me anyway, that the even one, that there's only one even one, and there's 2 odd ones. Isn't it weird? Counterintuitive. Okay. I don't know why that thing's crackling. I think there's a flaw in the cord. Okay. Here is a typical problem. Right away, you shouldn't be thinking about anything except cofunctions. So like cosine goes with what? Sine. So the answer on the top is sine of what? You watching? This is important. We're just getting the good stuff here. This is sine of theta. So if it's sine of theta, go over sine of theta. It'll cancel off nice, and the answer is just 1. All right. Another one. Could you... I'm drawn to this one right away because we've been talking about those. Instead of cotangent, what could you replace it with? Tangent of theta. And instead of cosecant, I could replace that with a whole bunch of things. Give me some options. 1 over sine squared, yes. What else? You could do the Pythagorean one, exactly. I don't remember which one it is either, but I could reconstruct it and solve it for cosine squared and find the Pythagorean one. Somebody must have had good notes and has the Pythagorean ones where it's like cosecant plus 1 equals secant or something. It's 1 plus secant equals cosecant. Thank you. 1 plus tangent equals cosecant. So there it is. I can replace this with 1 plus cotangent. And now I have cotangent down here. That makes it interesting. But I can replace that cotangent with tangent of theta. And then I'd have 1 plus cotangent squared over tangent of theta. Now I could replace the tangent of theta with what? 1 over cotangent. So that could become 1 over cotangent. And then I can do a flip and multiply. Anyway, I don't even need to finish this. My point is I just throwing things up that I think you should recognize. I'll throw a few more things up that I think you should recognize. Oh, you have to keep going until you get the problem down to as simple as you can. So let's do some actual ones that have nice clean answers. Here is a nice simple one. Cosine times tangent. Now, can you just do this in your head and say, oh, no, the answer is 1? No. Even if it was, which it isn't, you can't just say that. You have to replace each thing with something. So to do these properly, you replace cosine with something, and you replace tangent with something, unless you can just leave one of them as it is and replace one of them. Who's got an idea? Yes, sir. Replace what with what? Okay, but there's a faster way. That would work, but it would take a while. Yes? Tangent, you could put sine over cosine. And if you notice, this will work really nice, because if I leave this as just cosine, do you see how this will be over 1 and this will cancel this? And the answer is just what? And that's how you have to show your work. You can't just write down sine, because I can tell. When we're grading these on the test, if you don't replace sine, or like in this case tangent, with sine over cosine, if you try to do all this stuff in your head, we will not give you credit for it. Okay, so you have to show what you replaced it with. Let's do another one. Test is going to be next week, about a week from now, or a little more than a week from now, actually. We have some days that are going to be not as useful because, like, prom is coming on Friday, and so a lot of people will be gone. And anyway, so we have time in here to learn this stuff. But I'm thinking, honestly, we could probably have the test on Friday if it wasn't for the fact there's prom on Friday. Anyway, next one, secant x, cotangent x. Give me some options. Since they aren't squared, you're not going to use the Pythagorean ones. So, give me some options. Okay, instead of which one? So I'm going to replace secant with 1 over cosine. And replace cotangent with cosine over sine. That's a great idea. See what will happen? And I had some kids try to leave the answer as 1 over sine. Don't do that. You say 1 over sine is equal to cosecant. It is. The worksheet's all x. It is just a different variable. Doesn't matter. Okay, let's do another one. Cosine of x. Write this one down. I'm going to give you a second and see if you can do this yourself. You can look at your notes if you want to. If you don't have it in your notes, you'll have to reconstruct, which takes longer, but it's like a puzzle. Kind of agree with that statement. Now, it's not like you always guess right on the first try on what to replace things with. Like my first thought on cosine x is I could probably replace that with 1 over secant. But that might or might not work. I don't know. But I'd probably look at this first. Anytime you got a 1 plus and the thing is squared, that's probably one of those Pythagorean ones. So is it? What is it? It's secant or 1 over secant? It's just secant. Pretty sure it's just secant. Okay, so then, cosine of x, and this turns into secant, squared of x. Remember, it's squared. Okay, would you agree? Wait. Question first, yes? Okay, so next I'm going to change cosine to what? All right, so I'm going to make this 1 over secant. And this to secant squared, and I'm going to put it over 1 because fractions play nice with other fractions. You make them both fractions easier to see. And I bet you're going to ask me if you can just cancel off the secant. Okay, so you're recognizing that they're not exactly the same, but maybe they could cancel kind of? How about this? What if it had been 1 over x and x squared over 1? Could you have canceled off one of the x's? And it would leave one of the x's behind? It's the same exact kind of thing. It'll cancel off one of your secants, and this secant will be gone. And this won't cancel all of the secant, but there's secant times secant here. So just get rid of the squared. So the answer is secant over 1, which is just secant. Okay, those are typical problems. Let's go do one harder one. That's an R2 level. Number 6. That might be an easy R3 maybe, but okay, here's more of an R3. Sine x plus cosine x in parentheses. If you are writing these down, you are writing down homework answers, by the way. Squared minus 1. Now, a lot of people's first instinct is to say, oh, that's a different squares. We were just talking about that. See, it's something squared minus 1. 1 is a perfect square too. But that really won't work real well here. I'll save you a lot of time by don't try that way. You end up having to just try it and it doesn't work, but I'll save you the time. All right, so instead, how can you square this thing out? A lot of people forget that you can't just, it's not like this. If I have x plus y squared, that does not make x squared plus y squared. You remember that? Do you remember how if you had x plus y squared, you'd have to break it up into x plus y and x plus y and then FOIL it out? Does that ring a bell? Same thing. I can't just say the answer is sine squared plus cosine squared. I got to write it out like this. Sine x plus cosine x. Sine x plus cosine x minus 1. And then multiply it out. It's not that hard. That times that, I mean, I know it looks kind of impressive, but it's really not that hard. Sine squared x plus, now this part I do together, sine cosine, cosine sine, it's the same exact thing. So it's 2 sine cosines. And then the last, plus cosine squared x. All of that minus 1. Okay. Now we multiplied it all out. There must be something that we can do here. First of all, can I drop these parentheses? Is that okay? Yes. The only way I wouldn't be able to is if there was like something being multiplied out here or whatever. But there's nothing to do inside them. So I'm going to just drop them. Now, could I move this negative 1 anywhere I want in there? Sure I could. I could subtract 1 from any one of those. So like, what if you were to, for instance, move that negative 1 over here next to this, and then I'd have sine squared x minus 1. Does that look like one of those Pythagorean things? It is. What is it? Okay, and if you forgot, you'd go look on your sheet, and your sheet would say this. Cosine squared plus sine squared equals 1. And so you'd solve it for sine, and you'd, or wait a minute, I'd have sine minus 1, or be like if I move this over. No, that actually isn't. Let me think. That would be cosine squared is equal to 1 minus sine of theta. So the 1's supposed to be positive. Oh, look at that. That would be a really smart thing to do. Okay. Well, I was trying to do something really complicated, and you saw something that was much easier. You take this is equal to 1, right? That plus that equals 1, right? And then those two together making 1, and you add that with the negative 1, and they all end up canceling, right? So dumb, doink, doink, it's all gone. And now I've got 2 sine x cosine x. Now if we had, why did it cancel? These two together made 1. Do you get that? Because it says so right here. Fact. Cosine squared plus sine squared makes 1. And then the 1 and the negative 1 cancel. You get that? All right. Final answer, 2 sine x cosine x. And I know a lot of you are going to be tortured by this kind of thing, like, can I go any farther with it? I don't know if I can go any farther. If you get it down to just sine and cosine and they're not being divided, if they're being divided, then it's tangent, or it's cotangent. But if it's being multiplied, then you're done. Because you can't, like, make these things cancel each other. All right? So we did a bunch of problems off your worksheet. Your homework is your worksheet, which the answers are on the back side, because we know this is can be challenging, and you can check yourself right here and now. Don't have to even look online. And beyond doing the worksheet, you just need to finish what I told you to do yesterday. So some of you that were a little lost yesterday, use the time today. I got 20 minutes left here. Use it to come up and ask me how to do stuff. Hopefully you're a little smarter than you were yesterday now. But if you want to get help, good day to do it.